Earth is a mind-boggling 4.54 billion years old. At least it is at the surface. The rocks and minerals at the center of the Earth, on the other hand, are very slightly more useful. They formed at the same time as the rest of the planet, but recent calculations suggest Earth's core is nevertheless about 2.5 years younger than the ground immediately beneath your feet. This weird paradox is all tied up in Einstein's theories of relativity, ideas which play a vital role in the smooth running of a consumer GPS. In other words, Earth's core is aging more slowly than the planet's surface. Hi everyone, I am Sarvesh and welcome to SS World. The topic of this video is why Earth's core is younger than you think. There's no easy way to explain relativity. It takes years to fully understand Einstein's ideas, but they carry a simple message that is easy to understand. Reality is a lot stranger than it might appear. Our everyday lives tell us that certain things are reassuringly constant. An hour always takes exactly the same amount of time to pass, for instance, and the distance between two stationary objects never changes. In reality, both space and time are rendered malleable by the need to maintain a constant speed of light everywhere in the known universe. Strange as it seems, space and time are readily stretched and squeezed, depending on your position in the universe and the speed at which you are moving. Over the course of the average human lifespan on Earth, these differences don't add up in a way we would notice, although the differences are there nonetheless. For instance, when astronaut Scott Kelly began a year-long mission aboard the International Space Station (ISS) in 2015, he was 6 minutes younger than his identical twin brother, Mark, also a former astronaut. At the end of the mission, the age difference between the twins had changed by a few milliseconds. Over the course of the Earth's 4.54 billion year old lifespan, the differences add up in a more dramatic way. Since the second half of the 20th century, physicists have known that time has run at a slower rate in the Earth's core relative to the crust, due in part to differences in the pull of gravity at depth. Richard Feynman, a great American physicist, discussed the phenomena in a series of lectures in the 1960s. He said that the Earth's core should be a day or two younger than the surface by now. No one thought to check Feynman's math until 2016. Then, a physicist at Denmark and his colleagues ran the calculations for themselves and found that Feynman's oft-quoted figure is wrong. The core isn't 2 days younger than the crust. It's more than 2 years younger. It's easy to dismiss this sort of science as abstract. After all, none of us will ever see the deep interior of a planet. But relativity is anything but arcane. Adjusting for the effects of relativity ensures the GPS navigation apps built into smartphones and tablet PCs continue to work as they should. The GPS system is based on a series of very accurate clocks in satellites orbiting Earth. Those clocks tick at a different rate in orbit than they would at ground level, just as time passes at a slightly different rate for astronauts on the ISS. That's clearly a problem. GPS receivers in smartphones and other devices rely on the clocks in orbit retaining their accuracy. This is where Einstein's theories of relativity can help. They tell physicists that time passes slightly quicker on the satellites because they are moving at a high speed. And, confusingly, they also tell physicists that time passes slightly more slowly on the satellites because the pull of gravity is different in orbit. Taking both sources of error into account, scientists can calculate exactly how much the GPS clocks will drift each day and compensate for the error. Doing so keeps the GPS system working accurately day after day, year after year. On the face of it, Einstein's theories of relativity might seem to have a little impact on everyday life, but without them, many of us would be lost. So this is the end of our video. I hope you liked it. Subscribe and hit the bell icon for more interesting physics topics like this. Thank you.